Hello, 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 hello. Are you ready to learn about derivatives and math? Because I certainly forgot how to do them. Yeah, I love derivatives. Woohoo! Yeah, yeah, yeah. Also, I'm excited because I finally got a drawing tablet. And I can actually do my homework online now instead of turning in pieces of paper or like taking pictures of pieces of paper. But hope this works. Yeah, this is how it looks like, and okay, there we go. It works. It works. I tested this like 3 times. Look, I can write. Oh, I cannot write. I mean, I can write. Look, N-O-T-E-S. Long time no see. I see you can finally afford a room. Yeah, I can afford a room. Bed's so big. You know, I'm saving up space for my plushies. Okay, I need a giant bed so I can have more plushies. That's really why. That's really the only reason why you need a bigger bed. But today I'm gonna be using Khan Academy. This thing. Khan Academy is an amazing website to relearn derivatives and oh wait, hold on, and I set up background music. I don't know if it's gonna be really quiet because it's in the background. Bog brain, it's bog brain time. It's actually bog brain time. Oh yeah, do you like my photos in the back? I drew them myself. The two are on the right. I'm such a great artist, honestly. But I hope it won't be too loud. Part of the reason why I'm also playing background music is because I want to play these videos. However, I don't know if these will get like copyrighted. Khan Academy teaches you how to do horse archery in Croatia. I wish, that'd be cool. But no, we're gonna conquer derivatives today. Let's go. Might be a little loud. Okay, make it lower. Lower. And turn that lower. The thing is, I don't know if you can hear the video. That
mathematician and physicist.
Is this good? Is this good? Perfect. Okay, and you can hear like the video, right?
It's a picture of Gottfried Leib.
And also, I'm gonna play all the videos at 1.5 speed because I think it's a bit slow. Good. Everything's good. Yeah. Okay. I do have the transcript open and the closed captions. So we're gonna learn first why derivations are important.
This is a picture of Isaac Newton, super famous
Mr.
British
Khan, the person who made this.
This is a picture of Gottfried
website
Leibniz,
will explain
super
it to
famous,
us.
or maybe not as famous, but maybe should be famous German philosopher and mathematician. He was a contemporary of Isaac Newton. These two gentlemen together were really the founding fathers of calculus.
The founding fathers of calculus. I don't like you very much.
And this right over here is Usain Bolt, Jamaican sprinter, who's continuing to do some of his best work in 2012. And as of early 2012, he's the fastest human alive, and he's probably the fastest human that has ever lived. And you might have not made the association with these three gentlemen. You might not think that they have a lot in common, but they were all obsessed with the same fundamental question. And this is the same fundamental question that differential calculus addresses. And the question is, what is the instantaneous rate of change?
Instantaneous rate.
Usain Bolt, how fast is he going right now? Not just what his average speed was for the last second or his average speed over the next 10 seconds. How fast is he going right now? And so this is what differential calculus is all about. Instantaneous rates of change. Differential calculus.
Yes, rates of change.
Newton's actual original term for differential calculus was the method of fluxions, which actually sounds a little bit fancier. But it's all about what's happening in this
differential.
instant. And to think about why that is not a super easy problem to address with traditional algebra, let's draw a little graph here. So on this axis,
and then write calculus.
Distance. So and I'll say y is equal to distance. I could have said d is equal to distance, but we'll see, especially later on.
See, I can't write U. U L
And
LLUS.
I could say t is equal to time, but I'll just say x is equal to time. X is equal to time. And
I
so
like copyright.
Usain Bolt's distance as a function of
Lesson
time.
in copyright
Zero,
here.
To
Lands Academy.
Right
Ooh, you're allowed to stream the Khan Academy videos as long as you don't change people or the stream or lesson. Oh, okay. Thanks. That's good to know. That's very reassuring.
100 meters. And so using this information, we can actually figure out his average speed. His average, let me write it this way. His average
wait.
is just going to be his change in distance. His change in distance
Rate
over his change in time.
of
change in time.
change.
And using the variables over here, we're saying y is distance, so this is the same thing as change in y over change in x.
Oh yeah, I put it on 1.5 speed. Is it too fast?
This is the slope between these 2 points. If I have a line that connects these 2 points,
Slope.
if I have a line that connects these 2 points, this is the slope of that line. The change in distance is this right over here. Change in y is equal to 100 meters, and our change in time is.
I feel like the speed at one, or the normal speed, 1 time speed, is too slow.
Change in time is equal to 9.58 seconds. We started at 0, we go
But
to
I can play it at 1
seconds. Another way to think about it, the rise over the run, you might have heard in your algebra class, is going to be
rise over run,
over
yes.
9.58 seconds. So this is 100 meters over 9.58 seconds. And the slope is essentially just the rate of change, or you could view it as the average rate of change between these 2 points. And you'll see if you even just follow the units, it gives you units of speed here. It would be velocity if we also specified the direction. And we can figure out what that is.
Speed.
Let me get a calculator out. Let me get the calculator.
But you know, I want my chat to learn with me.
Meters in
That way I'm not
9.58 seconds.
I'm less alone.
9.58 seconds. So it's 10.4. I'll just write 10.4. I'll round to 10.4. So it's
Change.
approximately 10.
You have distance over time. That's
and then
speed.
The units are meters per second.
That's right.
Meters per second. And that is his average speed. And what we're going to see in a second is
Over
the average speed, how average speed is
time.
different than instantaneous speed. How it's different than the speed he might be going at any given
That's
moment.
average
Just to have a concept
speed.
of how fast this is, let me get the calculator back. This is in meters per second. If you want to know how many meters he's going in an hour, well, there's 3,600 hours in a 3,600 seconds in an hour, so he'll be able to go this many meters.
I'm actually gonna make it a
so
little bit faster.
If you were able to somehow keep up that speed in an hour. This is how fast he's going, meters per hour. And then if you were to say how many miles per hour, there's roughly 1,600, and I don't know the exact number, but roughly 1,600 meters per mile.
Oh, they're changing the units to hours.
So you see that this is roughly a little over 23, about 23 and a half.
Can't stay long, I need to go to bed.
This is approximately.
I couldn't go without saying hello. Well, hello, thanks for dropping by. And thanks for helping me with the audio and telling me about copyright. I appreciate it.
Let me scroll over so I don't have to bunch that. Miles per hour. And relative to a car, not so fast, but relative to me, extremely fast. Now, to see how this is different than instantaneous velocity, let's think about a potential plot of his distance relative to time. He's not going to just go this speed immediately. He's not just going to go, as soon as the gun fires, he's not just going to go 23.5 miles per hour all the way.
Oh, wait.
He's going to have to accelerate. So at first, he's going to start a little bit slower. So his slope is going to be
I'll
the average slope.
Message you. I was thinking about turning you into a mod, but I want to ask
steeper and steeper and steeper. And then maybe
I want to make sure that you're okay with it first.
Off a little bit. And so his distance plotted against time might be a curve.
I need to start
something like this.
adding
and what
people.
We calculate here is just the average slope across this change in time. But we can see at any given moment the slope is actually different. In the beginning, he has a slower rate of change of distance. Then over here, then he accelerates over here. It seems like his rate of change of distance, which would be roughly,
except for the
you could
next
view it as
few
the slope of the
sleeping
tangent
hours.
line at that point. It looks higher.
Okay,
than
have a
his
good
average.
sleep.
And then he starts to slow down again. When you all average it out, it gets to 23.5 miles per hour. And I looked it up. Usain Bolt's instantaneous
Yeah, I need to start
velocity,
adding mods.
instantaneous velocity is actually closer to 30 miles per hour. So the slope over here might be 23.
I also want to like mod the VTubers that I know, so like in case they show up, then I can immediately like see them.
30 miles per hour. But you see, it's not a trivial thing to do.
But I always want to
You can
ask
say, okay,
first,
let's try
because
to
I don't know.
approximate
I
the
feel
slope
bad if I
here.
just mod them
And you could do
immediately.
that by saying, okay, well, what is the change in
I mean, I know
y
that's
with the
kind of
change of
normal,
x right
but
around this? So you could say, well, let me take some change of x.
you're on controversy server. Yeah, okay, thank you. Okay, have a good sleep though.
So you get that, but that would just be an approximation because you see that the slope of this curve is constantly changing. So what you want to do is see what happens as your change of x gets smaller and smaller and smaller. As your change of x gets smaller and smaller and smaller, you're going to get a better and better approximation. Your change of y is going to get smaller and smaller and smaller. So what you want to do, and we're going to go into depth into all of this and study it more rigorously, is you want to take the limit as delta x approaches 0. as delta x approaches 0 of your change in y over
X approaches 0.
your
Oh, so
change
that's
in x.
like the
And
limit
when
thing.
you do that, you are going to approach that instantaneous rate of change. You could view it as the instantaneous slope at that point in the curve, or the slope of the tangent line at that point in the curve. Or if we use calculus terminology, we would view that as the derivative. So the instantaneous slope is the derivative. And the notation we use for the derivative is dy over dx. And that's why I reserved the letter y. And that's, you say, well, how does this relate to the word differential? Well, the word differential is relating, this dy is a differential, dx is a differential. And one way to conceptualize it, this is an infinitely small change in y over an infinitely small change in x.
Hello, welcome.
Super small changes in y over change in x, you're able to get your
We're learning about
slope.
derivatives.
In the case of this example, the instantaneous speed of
I kind of don't know
Usain
what's
Bolt
going on right now.
at that moment. And notice, you can't just put a 0 here. If you just put change in x is 0, you're going to get something that's undefined. You can't divide by 0. So you take the limit as it approaches 0. And we'll find that more rigorously in the next few videos.
As the limit approaches 0. Derivatives as a concept.
You are likely already familiar with the idea of a slope of a line. If you're not, I encourage you to review it on Khan Academy. But all it is, it's describing the rate of change of a vertical variable with respect to a horizontal variable. So for example, here I have our classic y-axis in the vertical direction and x-axis in the horizontal direction. And if I wanted to figure out the slope of this line, I could pick 2 points, say that point and that point. I could say, okay, from this point to this point, what is my change in x? Well, my change in x would be this distance right over here. Change in x. The Greek letter delta, this triangle here, it's just shorthand for change. So change in x. And I could also calculate the change in y. So this point going up to that point, our change in y would be this right over here, our change in y. And then we would define slope, or we have defined slope as change in y over change in x. So slope is equal to the rate of change of our vertical variable over the rate of change of our horizontal variable. It's sometimes described as
change in
rise over run.
And
for any line, it's associated with a slope because it has a constant rate of change. If you took any 2 points on this line, no matter how far apart or no matter how close
linear,
anywhere they sit on the line, if you were to do this calculation,
same slope for all of this line.
That's what makes it a line. But what's fascinating about calculus is we're going to build the tools so that we can think about the rate of change, not just of a line, which we've called slope in the past. We can think about the rate of change, the instantaneous rate of change of a curve, of something whose rate of change
you can find the rate of a curve.
So for example, here's a curve where the rate
can you
of
find it
change
like
of y
here
with respect to x is constantly changing. Even if we wanted to use our traditional tools, if we said, okay, we can calculate the average rate of change, let's say between this point and this point, well, what would it be? Well, the average rate of change between this point and this point would be the slope of the line that connects them. So it'd be the slope of this line, of the secant line. But if we pick 2 different points, we pick this point and this point, the average rate of change between those points all of a sudden looks quite different. It looks like it has a higher slope. So even when we take the slopes between 2 points on the line, the secant lines, you can see that those...
I don't know what that means.
But what if we wanted to ask ourselves an even more interesting...
What's a secant line?
What is the instantaneous
the line on like the
rate
curve?
Of change at a point? So for example, how fast is y changing with respect to x exactly at that point? Exactly when x is equal to that value. Let's call it x1. Well, one way you could think about it is, what if we could draw a tangent line to this point? A line that just touches the graph right over there.
Line?
And we can calculate the slope
so tangent line is like a line that touches the curve.
Rate of change at that point.
So there's a curve and it's just like that.
So in this case, the tangent line
might
look something like that. If we know the slope of this, well, then we could say that that's the instantaneous rate of change at that point. Why do I say instantaneous rate of change? Well, think about the video on the sprinters, the Usain Bolt example. If we wanted to figure out the speed of Usain Bolt at a given instant, well, maybe this describes his position with respect to time. If y was position and x is time, usually you would see t is time, but let's say x is time. So then if we're talking about right at this time, we're talking about the instantaneous rate. And this idea is the central idea of differential calculus, and it's known as a derivative. The slope of the tangent line, which you could also view as the instantaneous rate of change. I'm putting an exclamation mark because it's so conceptually important here. So how can we denote a derivative? One way is known as
use tangent line and
Leibniz is one of the fathers of calculus, along with Isaac Newton. And his notation, you would denote the slope of the tangent line as equaling dy over dx.
Hello.
Now, why do I like this notation? Because it really comes from this
Derivative.
idea of a slope, which is change in y over change in x. As you'll see
I don't know.
in future
I don't know
videos,
what's going
one way
on.
to think about the slope of the tangent line is, well, let's calculate the slope of secant lines. Let's say between that point and that point. But then let's get even closer. Say that point and that point. And then let's get even closer and that point and that point. And then let's get even closer.
Well, at that
And
point,
let's see
you're
what
just
happens
estimating the
as
curve
the
if you
change in
take
x
enough of those
approaches
points.
0. And so using these d's instead of deltas, this was Leibniz's way of saying, hey, what happens if my changes in, say, x become close to 0? So this idea, this is known as sometimes differential notation. Leibniz's notation is, instead of just change in y over change in x, super small changes
So
in y
differential
for a
notation
super small change in x, especially as the change in
includes
x
small changes.
approaches 0. And as you'll see, that is how we will calculate the derivative. Now there's other notations.
So I don't know how to
If this
spell,
curve is
so if I
described
spell
as
everything
y is
wrong,
equal to f of x, the slope of the tangent line at that point could be denoted as
differential
equaling
notation
f prime
includes
of x1. So this notation, it takes a little bit of time getting used to. The Lagrange
includes
notation.
small
It's saying f prime is representing the derivative. It's telling us the slope
values
of the tangent line for a given point.
slash
So if you
approaching
input an x into this function, into f, you're getting the corresponding y value.
approaching
If you
0.
input an x into f prime, you're getting the slope of the tangent line at that point. Now another notation
I'm sorry,
that
but I
you'll
can't
see
read
less
the
likely in a
language.
calculus class, but you might see
I
in a
only know
physics class,
English.
is the
I know
notation
it's pretty
y
pathetic.
with a dot over it. So
I only know
parentheses
how to read
y
English.
with a dot over it, which also
Maybe if you
denotes the
like
derivative.
Google
You might also
Translate
see
your
y prime. This would be more common in a math class.
your
Now, as we
message,
march
then maybe
forward in
I'll be
our
able to read
calculus
it.
Adventure, we will build the tools to actually calculate these things. And if you're already familiar with limits, they will be very useful, as you can imagine, because we're really going to be taking the limit of our change in y over change in x
Yes,
as
limits.
our change in x approaches 0. And we're not just going to be able to figure it out for a point. We're going to be able to figure out general equations that describe the derivative for any given point. So be very, very excited.
Alright, next video. Secant lines. You mentioned secant lines only now. But like, I don't know.
So right over here, we have the graph of y is equal to x
I
squared.
think I know what it is. I think it's like a bunch of lines
And the first thing I'd
along
like
the
to have is
curve.
think about the average rate of
I
change
think that's what a
of y
secant
with
line
respect
is.
to x over the interval from x equaling 1 to x equaling 3. So let me write that down. We want to know the average rate of change of y with respect to x
Okay.
over the interval from x going from 1 to 3. And it's a closed interval where x could be 1 and x could be equal to 3. Well, we could do this even without looking at the graph. If I were to just make a table here, where if this is x and this is y is equal to x squared, when x is equal to 1, y is equal to 1
There are
squared,
lines
which
that
is 1.
see
You
what we
that
can't.
right over there. And when x is equal to 3,
That's why we have to
y is
use so
equal to
many of
squared.
them. We have to exploit the
And
lines
so, you
so
see
that they
x is
can,
equal to 3,
so that we can see.
y is equal to 9. And to figure out the average rate of change of y with
Well,
respect
he's
to x,
plotted
say,
stuff.
okay, well, what's my change in
Okay.
x? Well, we could see very clearly that our change in x over this interval is equal
Uh-huh.
to positive 2. Well, what's our change in y over the same interval?
8.
Our change in y is equal to, when x increased by 2 from 1 to 3, y increases by 8. So it's going to be a positive 8. So what is our average rate of change? Well, it's going to be our change in
2
y
over, or,
over
oh no, 8 over
our
2.
change in
Yeah,
x,
y,
which is equal to
rise
8
over run.
over,
So you rise
2.
with the y and then you run with the
which is
x.
equal to 4. So that would be our average rate of change. Over that interval, on average, every time x increases by 1, y is increasing by 4. And how did we calculate that? We looked at our change in x. Let me draw that here. We looked at our change in x, and we looked at our change in y, which would be this right over here. And we calculated change in y over change of x for average rate of change. Now this might be looking fairly familiar to you because you're used to
It's a
thinking about
slope.
change in y over change in x as the slope of a line connecting 2 points. And that's indeed what we did calculate. If you were to draw a secant line between these 2
So
points,
basically,
we
rate
essentially
of
just
change, which
calculated
is the
slope of
derivative,
that
is the
secant line.
slope.
And so the
Okay.
average rate of change between 2 points, that is the same thing
change
as the slope of the secant line. And by looking at the secant line
Is
in comparison to the curve over that interval, it
R
hopefully gives you a visual intuition for what even average
T
rate
I
of change
V
means.
E.
Because in the
I don't know how to
beginning part of
spell.
this, you see that the secant
Rate
line
of change
actually
is the
increasing at a
derivative,
faster rate.
which
So
is the
then, as
slope.
we get closer to 3, it looks like our yellow curve is increasing at a faster rate than the secant line, and then they
Which
eventually catch up. And so that's why the slope of the secant line is the average rate of change. Is it the exact rate of change at every point? Absolutely not. The curve's rate of change is constantly changing. It's at a slower rate of change in the beginning.
Don't you just love my handwriting? It's so bad.
At a higher rate as we get closer and closer to 3. So over the interval, their change in y over the change in x is exactly the same. Now, one question you might be wondering is, why are you learning this in a calculus class? Couldn't you have learned this in an algebra class? The answer is yes. But what's going to be interesting, and is really one of the foundational ideas of calculus, is, well, what happens as these points get closer and closer together? We found the average rate of change between 1 and 3, or the slope of the secant line from 1, 1 to 3, 9. But what instead if you found the slope of the secant line between 2, 4 and 3, 9? So what if you found this slope? But what if you wanted to get even closer? Let's say you wanted to find the slope of the secant line between the point 2.5, 6.25 and 3, 9. And what if you just kept getting closer and closer and closer? Well, then the slopes of these
tiny secant lines
closer and closer to the slope of the tangent line at x equals 3.
So secant
if we can figure out the slope of the tangent line, well, then we're in business. Because then
can represent tangent lines.
We're going to be talking about instantaneous
one small,
which is one of the central ideas. That is the derivative, and we're going to get there soon. But it's really important to appreciate that average rate of change between 2 points is the same thing as the slope of the secant line. And as those points get closer and closer together, and as the secant line is connecting two closer and closer points together, as that distance between the points, between the x values of the points approach 0, very interesting things are going to happen.
When close together or together. Yeah. Oh, there's an exercise next. Ready to practice? I guess so. You ready, chap? You ready? Ready to do some math? Okay. What is the average rate of change of g of x equals 2x plus 3 over the interval 1 is, x is less than or equal to 1 and x is greater, x is greater than or equal to 1 and x is less than or equal to 3. Okay, let's try that. I'm gonna pick a different color for examples. Let's pick my classic blue, Okay. So, I'm gonna write rate of change. So type write average rate of change. Then you have g of x is equal to 2x plus 3. So you want to make a chart. We'll call this the x, and then we'll call this g. So you plug in x. In this case, you get 2. Actually, let me write it like this. Maybe it's a bit easier. 2, 1 plus 3. So that equals 2 over 4. That is 1/2. 1/2. Oh, no. Wait, no. I messed this up. Okay, 1. And this one is 1/2. Oops. Oopsie daisy. Okay, and then do the same for g of 3. So you get 2 plus 3 plus 3, which is 2 over 6. And that is 1 over 3. So 3, 1 over 3. So here we can find the change in x. The change in x is simply 3 minus 1. 3 minus 1. Yeah, 3 minus 1. Okay, and that's 2. And then we get change in g, which in this case, we'll need to... It's going to be negative. We need to find a common denominator so that it will work out. So we can try 6. We have 2 over 6 minus 3 over 6, because 3 over 6 is 1/2, and 2 over 6 is 1/3. We have negative 1 over 6. So do we just type in? How does this work? should be fraction. 1/6. Check. Not quite right. Huh? Oh, negative! I forgot the negative sign! Dang it! No! What am I doing? 2, 1, 3. 1/3 minus a half. 1/3 is 2/6 minus 3/6 equals 1. Yeah, negative 1/6, 2. Oh, no, wait, I'm so stupid. Hello, someone type sus. I don't know why, but hello. What's so sus about math? Okay, wait, yeah, okay. 2, and then 1/6. This is the correct one. I missed the last step, so it should be -12? Yeah, -12. Okay, you know, we're just gonna show all the steps, because I don't know what to do. 1/12. What? Oh, it's y/x. In this case, y is g. I'll pretend to know what you're talking about. I don't know what I'm talking about. I get this. I messed it up. My bad. We can redo this. I genuinely, like, it's been so long since I did stuff like this. Okay, so that's y. This is x. Then 1/6 divided by 2. So that equals 1/-12. Yeah. Math, this stream is messed up. Yeah, well, you know. I don't know what I'm doing. Good time to learn. It's a good time to learn. Next question. This time, I'm gonna get it right. Okay, next question. And then back here. So what is the slope of the secant line that intersects the graph of x at 1? So secant line int line. Whoa. L-I-N-E. Line. It intersects the graph. Good luck. Thank you. Oh, you know the answer for this? Okay, wait a second, and then let's like check. After I want to solve this myself too. That intersects the graph. Secant line. Oh, slope. Let me rewrite that. It's the slope of secant line. Slope of secant line. Then we have f of x 0.5 to that. Yeah. And then here we have the x. So we have 1 and 5, and now we need to find f. So this one should be 2, because f of x is, f of 1 is 0.5 over 1, or to the -1 power. I think that's 2. Okay, I'm gonna use a calculator for this, because I don't know. I think it's 2. You're too dumb for math? No, you're not too dumb for math. You just gotta try it out. I mean, I don't like numbers. I'm very bad at arithmetic, but I do enjoy math. I just forget everything. Okay, so it is 2. And then next you type in f of 5. So you have 0.5 to the negative 5th. Yeah. And I'm just going to plug this into a calculator because I don't know the answer. 0.5 to the negative 5th. 32. Okay, this time I'm going to get it right. I'm going to do the change in f first. That way I know that that's supposed to be at the top. So we have 32 minus 2, which is 30. I'd rather code than do math. But coding is math, you know? Like you have to learn about math before you code. At least that's how I was taught. I also learned how to code at one point in my life. Do I remember it? No. Because aren't algorithms based off of like math? Algorithms are all based off of math, and they just coded it. Or use different sort of algorithms. I don't know. I don't know what I'm saying. So that's 4. Then we have the change of f. Four and 36. And that is 9. 36 over 4. Yes. 9. 9. 9. The answer is 9. Please be correct. No? What? 5. Huh? Find the slope. That's 30. That's my handwriting. I literally said 30 out loud. 30. Get rid of that. Okay. Should be fun. 7.5. Thanks for the follow. Can I do math? No, I mean, clearly I can't do math. But you know, I'm trying. 30. 7.5. There we go. Next question. Will I get one of these questions correct? Who knows? Listen, doing math on stream makes me nervous, okay? Okay, average rate of change. Of change. Average rate of change. Oh, fx equal to x to the cubed minus 4. There's a math game me and my friends like to play if you're curious. It's a graph math. Oh, do share. Yes, do share. Okay, and then we have x. This one I will get correct. And this time I'll write neater. Graph wars. Oh, that sounds cool. Hold on, let me write that down. I want to remember. If I don't write it down, I won't remember. Graph wars. It's an artillery game. It's on Steam for free. Oh, even better. Thank you. Thanks for the recommendation. I'm always looking for you know, budget-friendly games. In this case, very friendly because it's free. Okay. So you take f of 2. 2 to the 3 is 8 minus 4, which then is 4, and that equals 2. To f of 5. Then we get 5 to the 3. Oh, nope, not an equal sign. 4. I'm gonna put that one in a calculator because I'm not doing that myself. I refuse to do that. Okay, the answer is just 11. Oh, nope. 11. Okay, this time I will get it correct. The first try. Here we have F. 11 minus 2 should equal 9. Yes. And X 5 minus 2 should equal 3. Yes. Math is your kryptonite. Don't worry, it is mine too. I mean, clearly. In that game, to shoot, you write an equation. Like just any equation or a specific equation. The one I use most is y equals x squared over 40. So you write a parabola. That's a parabola, I think, because it's x squared. So it's got a U shape. Oh. I want to play it. Yeah, I'm gonna put it on my list. And then I want to see if I can maybe find other VTubers to stream it with. But I definitely want to try and play it. So, change in F over change in X is equal to 9 over 3. That's 9, right? I'm not writing anything wrong. 3, 9 over 3. And 9 over 3 is 3. I'm getting nervous. I finally got it right. Push it. Jeez. I made such stupid mistakes earlier. Oh. Okay. What is the slope of the secant line that intersects the graph of g of x 3 to power of 2 times x, and x is equal to 0 and 2. Okay. Do not make stupid mistakes. Go write down the question carefully and don't make your zeros look like 6s. Slope the secant line. Secant line. Slope secant line of... Oh, my thing is lagging a little bit. Computer, please do not die on me. 3 to x. X is equal to 0. And x is equal to 2. The most basic attacks are just you writing y equals x. Oh, it's just like a straight line, I think. Right? With y equals x. It's like a... Pen, hello, work, please. Okay, that's bad graph, but like this, right? Like we have y and x. And then slope of 1. My pen is dying. It doesn't even have batteries, and why are you dying? I think it's just my computer. Basically going up or down. Oh. I definitely want to play it. So let's make the chart again for this question. So we have g of x. Oh, g of 0. 0. We have 3, 2 times 0, which in this case it would be 1. And g of 2. So that'll be 3, 2 times 2. That'll be 3 to the 4th. 3 times 3 is 9. The 9 times 9 is 81. So it should be 81. So let's make the chart. We have x and g. We have 0, 2, 1, and 81. So change in g should be equal to 80, and change in x should be equal to 2, and 80 divided by 2 is equal to 40. Yeah, 40. I hope. I got it right. I got a 50%. That's terrible. There are variants. You can play with these. Oh, so like the y is squared or cubed. The game is not able to go full screen. I think that's okay. I'll figure out a way, you know. 2 out of 4. This hurts my soul. Let's find like a little more space. That's only a 50%. Okay, let's go next. Actually, I'm gonna take a sip of water. Remember, when doing math, remember to stay hydrated. You know, maybe that's why I made so many stupid mistakes. It's because I didn't hydrate properly. Lagranges. Notations. F prime. Lesbin's notation is dy over dx, and Newton's notation is y with a little dot. He just said the name too, but I forgot. What is derivative notation? Derivatives are the result of performing a differential process upon a function or an expression. Derivative notation is the way we express derivatives mathematically. This is in contrast to natural language, where we can simply say the derivative of Lagrange's notation. The derivative of f is expressed as f prime. This notation is probably the most common when dealing with functions with a single variable. If instead of a function we have an equation like y is equal to f of x, we can also write y or y prime to represent the derivative. This, however, is less common to do. Where are you from? I am American. I'm just bad at reading, and also I have a very, very high chance of being dyslexic. So if that explains anything of why I can't read and why I can't write, there you go. American. Yeah, I'm American. Okay, lay business. The derivative of f is expressed as d f of x over dx. When we have an equation y equals fx, we can express the derivative as dy over dx. Here, d over dx serves as an operator that indicates a differentiation. Yes, differentiation with respect to x. This notation also allows us to directly express the derivative of an expression without using a function or a dependent variable. For example, the derivative of x squared can be expressed as d x squared over dx. I'm from Italy. Whoa, you're from Italy? I always want to go to Italy. I'm probably not going to be able to go for a long time. Also, If you think, why not get it tested by a doctor? So here's the story. Ever since I was a kid, a bunch of teachers would tell me, like, oh, she should get tested. Well, tell my parents. They would be like, oh, you know, she should get tested. Do you know how much it costs? It costs $2,000 to get tested. $2,000! So that is why I am not tested. So I have had, I think, like 9 different teachers tell me that I have a very high chance of being dyslexic, and I show all the symptoms of being dyslexic. And in terms of letters, for me, numbers don't really affect me. At least I don't think they do. But yeah, I don't have that money. And even if I did have that money, I would not spend it on a test. Like, I can just deal with not being able to read. I would rather spend the $2,000 elsewhere. This notation, while less comfortable than Lagrange's notation, becomes very useful when dealing with integral calculus, differential equations, and multivariable calculus. Yuck. Newton's notation. In Newton's notation, the derivative of f is expressed as f dot, and the derivative of y equals f of x is expressed as y dot. I don't even know how to say that. This notation is mostly common in physics and other sciences, where calculus is applied in a real-world context. You are dyslexic as well, if I am. You have dyslexia and ADHD. I heard that that's very common for people to have both. Like, if you have dyslexia, you have a higher chance of having ADHD compared to someone who doesn't have dyslexia. I don't know if that's true, and also I'm not qualified to say anything, so yeah. How can we express the derivative of square root of x? This, I think. Check. Yeah. Couldn't grade your answer. What? There are 2 of them? Oh, there's 2 questions. How can we express the derivative of cosine x? This, I think. Yes. Derivatives as the slope of a curve. Got tested years ago. As a kid, I was thinking it was just extra homework not to see that. Oh. I don't want to do extra work. Oh, so they made you do, like, extra exercises? Well, I never got officially tested, so I never got, oh no. For me, it was always my reading speed, my horrendous spelling, and my inability to, like, connect sounds and words. So that was kind of how teachers have detected that I've had it. That being said, it doesn't really matter. They made me write and read to see. Oh. Oh, so they test you by doing extra writing and reading. Okay, that makes sense. So it's like an extra assignment to test. Oh, okay. Yeah, over here, you gotta fork up a lot of money. They don't do that.
What I want to do in this video is a few examples.
Whoa, this one's so quiet.
Intuition of the derivative as a rate of change, or the steepness of a curve, or the slope of...
Okay, I'm gonna pause the background music, and I am going to increase the sound that we can hear what Sal is saying.
Or the slope of a...
The inattentive type. Oh yeah. I know a lot of people who also have ADHD. But they're also different types. I think, like you said, like you have the inattentive type. I also know like there's like ADD without the hyper, and that also is kind of similar, but also affects them like differently.
What I want to do in this video is a few examples that test our intuition of the derivative as a rate of change, or the steepness of a curve, or the slope of a curve, or the slope of a tangent line of a curve, depending on how you actually want to think about it. So here it says f prime of 5. So this notation, prime,
The
is
derivative
another way
of
of saying, well, what's
f.
the derivative? Let's estimate the derivative of our function at 5. And when we say f prime of 5, this is the slope of tangent line at 5, or you could view it as the rate of change of y with respect to x, which is really how we define slope, respect to x of our function f. So let's think about that a little bit. We see they put the point 5 comma f of 5 right over here. And so if we want to estimate the slope of the tangent line, or if we want to estimate the steepness of this curve, we could try to draw a line that is tangent right at that point. And so let me see if I can.
I think you're gonna make us do like a secant thing again.
Starting there, if I just wanted to make it tangent, it looks like it would do something like that. That right at that point, that looks to be about how steep that curve is. Now, what makes this an interesting thing in nonlinear is that it's constantly changing. The steepness, it's very low here, and it gets steeper and steeper and steeper as we move to the right for larger and larger x values.
Yeah.
But if we look at the point in question, when x
It's almost
equals
linear
5,
up here too.
remember, f prime of 5 would be, if we were
It
estimating
looks
it,
almost
would be the
linear because
slope
it's
of
so
this line
steep.
here. And the slope of this line, it looks like for every time we move 1 in the x direction, we're moving 2 in the y direction. Delta y is equal to 2 when delta x is equal to 1. So our change in y with respect to x, at least for this tangent line here, which would represent our change in y with respect to x right at that point, is going to be equal to 2
So have a
over
tangent
1
line.
over 2. And
And
we can also
then
estimate it, but all of
find
these are way off. Having a negative 2 derivative would mean that as we increase our x, our y is decreasing. So if our curve
change
looked
in
like
x.
this, we would have a slope of negative 2. If having slopes in this a positive of 0.1, that would be very flat. Down here we might have a slope closer to 0.1. Negative 0.1, that might be closer on this side, where it's downward sloping but very close to flat. A slope of 0, that would be right over here at the bottom, where right
It's
at that
flat.
moment, as we change x, y is not increasing or decreasing. The slope of the tangent line right at that bottom point would have a slope of
0. Yeah.
I feel pretty good about that response.
Okay, I do remember that.
So, all right. So they're telling us to compare the derivative
Oh.
of g at 4 to the derivative of g at 6, and which one of these is
Compare.
greater.
Okay.
And like always, pause the video and see if you could figure this out.
Okay,
Well, this is
I'm gonna
just
pause and see if I can figure this out. Kind of annoying though, Gen Z fakes disorders for attention, even though I'm Gen Z. Well, I honestly feel like that's most normal people, most normal Gen Z people don't actually do that. It's just online and it's like bad. And of course, anything that is kind of controversial online gets a lot of attention. But yes, it is bad that people fake it. It's even worse when people fake something and then ask for money. I would like despise that. Okay, 4. So here's the little line. I mean, how do I... Here. So that's like at G4. The slope at x equals 4. At x equals 4. Yeah, slope of x equals 4. So you rise. So it looks like a 1.5. So 1.5, and then you run. Oh, you run 1. So that's 3 over 2 over 1. So it's just 3 over 2. What type of engineering do you study? Okay, I'm a bit hesitant to answer that, and not in like a bad way. It's because I'm really stupid. And I don't want people asking me questions. But I'll just say this. I've learned coding previously. I've learned, of course, calculus previously. And I learned about let's say physics. I learned that. So one of those engineerings that falls under all those categories. That's what engineering I am. Someone told me they will hack. Someone told me they will hack me. I asked them what language they code in. Wait, they said numbers. Thanks for dropping in, Cupcake Conjurer. I appreciate it. I always appreciate when you stop by. Thank you. Electrical. You know, I cannot confirm nor deny, but that's all I'm gonna say. I just don't want people asking me questions. Maybe one day I'll reveal. I mean, it's not gonna be that surprising of a reveal, to be honest. But yeah. If you're studying this type of math, you're smart. That's how I feel. Here's the thing. I don't remember any of it. When you actually like get into doing some stuff, like you don't use, well, you do. You do use it sometimes, but it's never like I guess I can say I've forgotten the fundamentals of everything, and I'm terrible at coding, so I shifted away from coding. I do not know how to code. You see, that's the point. I'm doing engineering stuff that is shifting away from coding because I hate it, and I don't know how to do it. Why do you feel stupid when you clearly know how to code? I don't know how to code anymore. My first official coding language was C++, but I don't remember. I know what a for loop is. I know what a while loop is. I used to know what pointers are, and I don't anymore. Okay. But basically, this is kind of asking which one has a steeper slope. This one, g of x, or g prime at 6 has a steeper slope. I don't really know how to calculate that one. You can go 1... Oh, here. Let's go around like... So it rises 2 and goes over 1. So it'll be 2 over 1, which is 2. And 2 is bigger than 3 over... Let's see if I did that right.
Let's see if we were to make a line that indicates the slope there, and you could view this as a tangent line. So let me try to do that. So no, that doesn't do a good job. So right over here so that looks like I think I can do a better job than that. No, that's too shallow. Let's see, not shallow, it's flat. Let me try to really, okay, that looks pretty good. So that line that I just drew seems to be indicative of the rate of change
well, that's not
with respect to x, or the slope of that curve, or
that's not what I got. But I still think this is valid. I still think
if we go further down over here,
this one g prime at 6 is bigger because it's a lot steeper. Yeah.
So it looks like it is.
Oh wait, in the negative direction. I forgot negatives. No, the other way around.
Increase. Think of it this way: as we increase x
negatives
1 here, it looks like we are decreasing
y
by about 1. So
it looks there we go.
G prime of 4, the derivative when x is equal to 4 is approximately, I'm estimating it, -1. While the derivative here, when we increase x, if we increase x by 1,
I guess I should put the little squigglies because it's an estimation.
Close to 3. So g prime of 6 looks like it's closer to -3. So which one of these is larger? Well, this one is less negative, so it's going to be greater than the...
Yeah, okay, I got it right later.
Just look at the curve. This is some type of a sinusoid here. You have, right over here, the curve is flat. You have, right at that moment...
Sinusoidal curve.
Then it starts to...
That sounds fancy.
And it decreases at an even faster rate. Then it decreases at a faster rate. Then it's still decreasing, but it's decreasing at slower and slower rates. Decreasing at slower rates, and right at that moment, it's not, you have your slope of your tangent line is 0, then it starts to increase, so on and so forth, and it just keeps happening over and over again. So you can also think about this in a more intuitive way.
All right, we'll go to the exercise. We are not cavemen. We have technology. Totally not a SpongeBob reference. I never watched SpongeBob as a kid. I'm a bit sad. Well, I did. I didn't have, like, TV. I didn't have cable TV, and it was only on cable. Okay, go here. Here. Do some of these exercises. So, which is greater? Or less than or greater? But I know the meme that you're talking about for SpongeBob. SpongeBob, the animation is just so memeable because they're so expressive. Okay, let's see at 1. So this bottom one's at 1, and this one is at 6. So they're both positive curves. I'm actually not gonna draw it. I'm just gonna eyeball it. Let's see if I eyeball it. Okay, one looks like a lot steeper. So S-T-E-E, steep. And this one looks a lot more flat. So I'm gonna go with that one. Hope it's right. Yay! Whoa, that was kind of loud. Oh, my background music. I forgot to turn it back on. Okay. Next question. That's a little too quiet. Okay, sorry for all the computer noises. Okay, estimate. What? F. Oh, my pen is really lagging. What F prime one day? F prime at 3. So go to here. So this is a negative slope because it's going to like this. Negative. Negative slope. And it's gotta be 3 or 1/3. It's 3. I can't tell. So it rises or it goes down 1 and then it runs 3. Like that. I'm gonna go with D. I'm thinking of visiting America one day. Only have 2 places in mind so far, New York and Alaska, and another state. I can't remember where the natural forest / park is. Oh, you have to go to Yellowstone. If you do come to America, like that's New York and Alaska, they're nice. But is Yellowstone the one you're talking about? I think that's in Wisconsin. No, Wyoming. Let's start with W's. Hold on, let me search it up. Geography. I don't know geography. Where is Yellowstone? Wyoming. It is Wyoming. not Wisconsin. Wisconsin's more to the east, I think. Oh, not Yellowstone. Well, if you do plan on going to like a natural forest / park, I would suggest Yellowstone. It is absolutely beautiful there. There are hot spring geysers, and they shoot hot water. Bison. Yay, I got it right. Negative 1/3. But yeah, I highly suggest Yellowstone, unless that's not your like sort of thing. I know some people don't really like hiking and stuff like that. Actually, I don't even like hiking that much either, but depends what you would like. New York is mostly to visit 2 sites and the museum of that one. Oh, okay. I mean, New York also has different museums that have not necessarily of that day. A bit more happier. I think you could go to them and also on the same day, or in the same time you visit them. Tried a dollar pizza. New York pizza is so thin. Wait, you're from Italy. Wait, why do you... Oh, it's $1, I guess. I was like, if you're from Italy, why would you want to try American pizza? New York pizza is really good, though. In my opinion, I've never tried, like, authentic Italian pizza, so I would not know. Okay, which is more steep? So this one is a lot more flat, and they're both positive. This one's more steep. Chicago style pizza. I love Chicago style pizza. I think that's my favorite style. Yes, you have to try Chicago style pizza. Okay, that one is really different than, like, I guess I would assume the Italian or the more traditional Italian pizzas. Chicago style pizza is great. So this is the steep slope, and this one is more flat. So if it's steeper, then it's greater, so it should be A. Chicago style pizza is definitely, if you love cheese, you'll love Chicago style pizza. It's amazing. Okay, and then estimate. Let's do the same thing. We have G prime at 4. And that is a negative value, so it's either this one or this one. And it looks pretty steep, so I would not say less than 1. Oh, Yosemite! That one's actually pretty good too. I've been to Yosemite. I personally prefer Yellowstone. However, Yosemite is beautiful. A lot of trees. I think it's -3 because how steep this negative slope is. Oh no, I clicked too quick. Oops. Well. Also, Grand Canyon should be a must. Grand Canyon is nice. Sometimes, I don't know, it's me because I'm a little scared of heights. It's beautiful, just, you know, don't look down too much. You might feel nauseous. Unless you're not scared of heights, then don't worry, you'll be fine. Why is this one so quiet? Okay. Let me pause this. Increase the volume. Sorry for, like, random computer noise.
At the point 2, 3.
Okay, that's still too quiet. Why is that Vegas so quiet?
Through the point 7, 6.
Oops, I made dots.
F prime of 2. So whenever you see something like this, it doesn't hurt to try to visualize it. You might want to draw it out or just visualize it in your head, but since you can't get in my head, I will draw it out. So let me draw the information that they are giving us. So that's x-axis, that is the y-axis. Let's see the relevant point.
That's such a straight line.
7, 6. So let me go 1, 2, 3, 4, 5, 6, 7 along the x-axis, and I'm going to go 1, 2, 3, 4, 5, and 6 along the y-axis. And now this point, so we have the point 2, 3. So let me mark that. So 2, 3 is right over there. So
2, 3 point. Okay.
And we also have the point 7, 6. 7, comma 6 is going to be right over there.
Tangent line to the
6.
graph.
Let's remind ourselves what they're saying. They're saying the tangent line to the graph of function f at this point passes through the point 7 comma 6. So if it's the tangent line to the graph at that point, it must go through 2 comma 3. That's the only place where it intersects our graph.
2.
And it goes through 7 comma 6. So you only need 2 points to define a line. And so that
Can't you just find
it's going to look like
the change?
No, that's not right. Let me draw it. Like it's going to look. Oh, that's not exactly. One more time.
I like how he just messes it up.
So
He's like, oh, oops, that's not right.
It goes, it's tangent to f right at 2 comma 3, and it goes through the point 7 comma 6. And so we don't know anything other than f, but we can imagine what f looks like. Our function f could, it could look something like this. It just has to be tangent. So that line has to be tangent to our function right at that point. So our function f could look something like that.
Okay, that's a terrible looking function.
F prime of 2, they're really saying, what is the slope of the tangent line when x is equal to 2?
Okay.
When x is equal to 2, well, the slope of the tangent line is the slope of this line. They gave us the 2 points.
Yeah, okay, that's what I was thinking. Like, couldn't you just calculate the slope of the 2 points and then subtract like 6 minus 3 and then 7 minus 2 and then get the change?
So let's do that. So as we know, slope is change in y over change in x. So if we change to go from 2 comma 3 to 7 comma 6, our change in x, we go from x equals 2 to x equals 7. So our change in x is equal to 5. And our change in y, y equals 3 to y equals 6. So our change in y is equal to 3.
Yes.
So our change in y over
3 over 5
is going to be 3 over 5, which is the slope of this line, which is the derivative of the function at 2, because this is the tangent line at x equals 2. Let's do another one of these. For a function g, we are given that g of negative 1 equals 3 and g prime of negative 1 is equal to negative 2. What is the equation of the tangent line to the graph of g at x equals negative 1? All right, so once again, I think it will be helpful to graph
equation of tangent line to the graph of g at x equals negative. Oh, so wait.
X-axis.
Oh,
let's see.
They give you the point and the derivative.
That g of negative 1 is equal to 3. So the point negative 1 comma 3 is on our function. So this is negative 1.
Negative 1.
1, 2, and 3. So that's that right over there. That is the point.
And the slope is negative 2.
It's going to be on our function. And we also know that g prime of negative 1 is equal to negative 2. So the slope of the tangent line right at that point on our function is going to be negative 2. That's what that tells us. The slope of the tangent line when x is equal to negative 1 is equal to negative 2. So I could use that information to actually draw the tangent line. So let me see if I can do this. So it will look, so I think it will, let me just draw it like this. So it's going to go, so it's a slope of negative 2 is going to look something like that. So as we can see, if we move positive 1 in the x direction, we go down 2 in the y direction. So that has a slope of negative 2. And so you might say, well, where is g? Well, we could draw what g could look like. G might look something like this, might look something like that, right over there, where that is the tangent line. We could make g do all sorts of crazy things after that. But all we really care about is the equation for this green line. And there's a couple of ways that you could do this. You could say, well, look, a line is generally, there's a bunch of different ways where you can define the equation for a line. You could say a line has a form y is equal to mx plus b, where m is the slope and b is the y-intercept. Well, we already know what the slope of this line is. It is negative 2. So we could say y is equal to
negative 2x.
Negative 2 times x.
And then plus 1.
Plus b. And then to solve for b, we know that the point negative 1 comma 3 is on this line. And this goes back to some of
Oh, they're going to actually plug it in to solve it. Oh, okay.
So negative 1 and 3 for
I was going to be like, it intersects at 1, so that means b is 1.
So 3,
I think that's how you can solve it.
Is equal to negative 2
times negative 1
times negative 1 plus b. And so let's see, this is negative 2 times negative 1 is positive
2.
And so if you subtract 2 from both sides, you get 1 is equal to b. And there you have it. That is the equation of our line.
Yes.
Y is equal to negative 2x
plus 1.
And there's other ways that you could have done this. You could have written the line in point slope form, or you could have done it this way. You could have written it in standard form, but at least this is the way my brain likes to process it.
Okay. Time to do an exercise. Probably the coolest place I'm planning to visit is Antarctica. Oh, don't freeze. It won't be fun. It won't be as fun going alone. Yeah, traveling alone is not as fun sometimes. However, it's kind of nice. I don't know, unless I'm a bit of a loner. So, like, I choose to be a loner. When I say when I'm a bit of a loner, I mean I choose to be alone. I'm literally learning Khan Academy. So yeah, I personally think traveling alone would be nice. The only thing is, like, I guess you can't rely on someone else, like, if you need help. Or for safety reasons. Just so you're gonna travel to Antarctica, just so I can say. Honestly, that would be cool. Do they sell, like, souvenirs from Antarctica? You could wear, like, bring back a souvenir and take a picture of you holding it there so that you can say that you've been there, and with proof, with evidence. Antarctica would seem nice, but I'm a bit too worried. There isn't much food, or there isn't much of anything. I can... A block of ice. Okay, for function h, we're given that h is -2 equal to -5, and then the slope of that at -2 is equal to -9. What is the equation of the tangent line to the graph at x equals -2? Tangent line to the graph at x equals -2. Okay. How do I do this? Let's see. This time I'm gonna draw it. It's gonna be terrible drawing. Let's see. -9. So let's go, that's -2. -9 is gonna be a lot further. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I wrote 10. We have -2, 1, 2, 3, 4, 5. So, like, over here. And then the slope of this is -9. Wait, no, it needs to be even more lower. Because it's 10. Okay, basically it looks like this. Oh, nope. There's just, like, more, just pretend there's, like, more stuff. I'm not counting. Something like that, and let's just say, moves over 1. 1? And this is -9. Oh, the background music and my volume. Hold on, let me bring those things back. Here we go. Traveling so I have someone to goof around with. Because if I goof around alone, I look awkward and weird doing that. That's true. I guess. So, what was the other one? So we have the slope of... How do I do this? Okay, so we have the slope of -9. So we have y equals mx plus b. And then n is -9. I don't know what this is for. Like, why did you make it in this notation? It makes it so much more difficult. You can plug in -5 for y is equal to -9 times -2 plus b. 9 times 2 is 18. It's positive 18, so we have... Actually, and then you bring it over to this side. So we have -5 minus 18 is b. And that is -23. So if you keep it in the y equals mx plus b form, you have... Oh gosh, my computer might be dying. Or, I mean, it is dying. The lag on my pen is really bad. You have -9. X... That's so bad. 23. Yeah, so this is the answer. However, they wrote it like this, and I don't know which one. So it's got to be either one of these two. We have... So this ends up being -45, so that's not right. So... So for this one we have, 18, so that's -18 minus 5. Okay, yeah, this one. Oh, I highlighted it. Oops. It's C. No, what? Okay, it's C. Because 9 times 2, or -9 times 2 is -18 minus 5, which is -23. Yeah! Okay. Because why not? But it makes my life so much harder. Yeah, my computer's overwhelmed by the pen. Okay, maybe I'll finish this lesson and then... I'll finish this lesson and then... I think I gotta give my computer a break. Okay, graph of G at the point 6 minus 2. I can write, I swear. Your writing is great. I'm gonna be honest, especially... I'm gonna assume that English is not your first language. Your writing is great, especially in English. Like, I can understand you, and that's all that matters. There are a lot of people in my chat who come in sometimes who have English as, like, a second language. And they're always like, I'm sorry, my English is not great. I'm like, as long as I can understand you, you're doing good. Okay. So at that point, passes through that point, passes through 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 the point. Oh, my computer is really struggling. Okay, maybe after this problem set, I'm gonna give my computer a break. Find E prime at -6. Okay. A tangent the tangent line to the graph of function g at point -6, 2 passes through the point 0, 2. Find g prime at -6. So what do I do here? Okay, g passes to the point, find g prime at -6. So it's just a difference because -6 is already given. So let's just put like an example point. I'm not actually going to draw the graph. So you have -6 and -2. And then we have 0 and 2. That's 0. Then we find the slope, or find the change in that. So we have -6 minus 0. 0 is equal to -6. So that is the change in x. And then we have the change in y. So we have -2 minus 2, which is equal to 0. So we have change in y over change in x. But that doesn't make sense. Hold on. 2 minus 2. Why? There should be 4 change. Change in 4. Oh, wait. No, I did it wrong. It's a positive slope. Okay, let me redo that. So we have, it's a positive, yeah, it's a positive slope. So you have 0 minus, and then -6. So change in y is 6. And then we have 2 minus -2 is 4. So that is equal to the change in y. My pen is struggling so badly. And then we have 4 over 6. Yeah, 4 over 6. That's a 3. I need to write a 6. 4 over 6. And then that can simplify to 2 over 3. Hopefully that is correct. I hope. 2 over 3. Yay! I am fluent in English, just dyslexic, that's a problem. I learned 3 languages at the same time. What the heck? 3 languages. 3 languages. I can't even speak one properly. I'm going to take my shower and cook up some pizza. Well, by the time you're back, maybe I might end because clearly my computer can't handle my pen. But if you're gone already, I'll be back. The VOD will be here. But thanks for showing up if you do, if I'm not still here. Yeah, I'm sorry. Thanks for popping by. Like, you don't have to stay, by the way. Like, leave whenever you want. I don't want to make you feel bad. I will be ending the stream soon after this problem's set, because I think my computer might crash, and I don't want it to crash. Okay, function G. 2 more questions. Oh my gosh. G. You're given G of -6. -8. Okay. And then G up at -6. I stay either way. Not to be rude. Don't worry. You know, swearing is allowed. I think. Or, well, I don't know. Depends on whether my bot is okay with it. Because I have a bot that protects me from certain stuff. But apparently, like, people have swore in my chat, and it automatically, like, banned them, even though that's not what I wanted. I stay either way. Don't worry, you're not being rude. I understand. Okay, so we have this function. We have the 2 values, and we have the slope. What's the equation of the tangent line to the graph of g at x is equal to -g. equation of the tangent line. Okay, so same thing like the previous one, and it's written in this stupid notation that I hate. Why? It makes it so much harder to read. Hello, Yoshio! You wanna watch me finish my last 2 questions before I end stream? My pen is dying, and I mean, my computer is dying, it can't handle my pen. So late. I'm gonna go, it's 2 a.m. for you? Yeah, feel free to leave. Make sure to get some sleep. Thanks for stopping by and thanks for following. Okay, and where do I start? Okay, so y equals 10, please. Please work. There's only 2 more questions. I know you're struggling, but please work. Oh, yeah, I said good night. I mean, good morning. Have a good morning and get some rest. So we have m is equal to 3. Yes, because that's the slope. And then we can plug in -8 for y. Plug in 3 here. Plug in -6 plus b. So we have -18. -8. -18. Oh, it's going plus b. And then I bring over the 8 to the other side, so you have 18 minus 8 plus b. Come on, please survive. 10. I don't know if you can see it. I think you can. 10. There we go. So our form is y is equal to 3x plus 10. That's 10. And then we look over to here, see which one. So it can only be these 2. And we can check. So 3 times 6 is 18. And then we have 18 minus 8. So it should be this one. Yeah! Okay, one more question. I'm sorry, computer. I'm pushing your limits. But survive. It does not like me right now. Okay, tangent. Tangent line of the graph of function x. Function h. Not x. Function h. At point 3, 8 passes through point -1 0. So we have like -1 0 goes to 3 over 3 8 3 comma 8, and to find the derivative of that, to find the slope, so change in y would be x or 8 minus 0, and that is delta y. Oh boy. 3 minus, okay, come on, last question, please do not die on me. Okay. So that is 8. 8, okay, it's showing up, We have 3 and 4. Oh boy. Okay, last question. It's so bad. 8 over 4 is equal to 2. So we have h prime at 3 is equal to 2. Yay! Yay! We got 100%! Okay. I think I'm gonna end or wrap up the stream, but thanks everyone for coming. I appreciate it. I had a lot of fun relearning everything. Looks like I might have someone still watching on YouTube, but I'm gonna raid someone on Twitch. So Let's see who to raid. Let's see if anyone's on. And anyone I follow is on. Oh, Mai is on. Okay, this is a Mai. He's really cool. He's really nice. He's just a silly guy. And we're gonna raid him. I'm gonna put the link in the YouTube chat if you're on YouTube, if you would like to join us in the raid. I need to get better at this. It's so bad. Okay, I'm gonna put this. And do not accidentally clip the thing. I'm gonna go. And we're gonna raid in 10 seconds, so I'm gonna go to this screen. Yeah, but thank you, I appreciate it. I had a lot of fun today. I hope you join me in raiding. Okay, bye, be nice to him.